August 1943, occupied France. A single American P-47 Thunderbolt falls into German hands nearly intact. What looks like a crude, overweight fighter becomes a revelation. Inside its steel and aluminum lies proof that Germany isn't losing the air war, it's losing the war of industry, and it doesn't even know it yet. 1st August 1943, occupied France. Long before dawn on a quiet Luftwaffe airfield far from the front lines, German mechanics and guards gather around something that should not be there. A massive American fighter shot up battered but unmistakably intact rests on German concrete. Its pilot is already in custody. The aircraft is the real prize. For months, Luftwaffe pilots have been reporting encounters with this machine. A fighter that dives faster than expected, that absorbs punishment that should be fatal, that still fights at altitudes where German engines begin to choke. Now, for the first time, the enemy is no longer a rumor in combat reports. It is real, silent, waiting to be dissected. At first glance, the reaction is almost dismissive. The aircraft looks crude, huge, bloated, overbuilt. Nothing like the sleek, knife-edged German fighters engineered to squeeze maximum performance from minimal weight. Some officers smirk. Others shake their heads. This is what the Americans are flying. But war is not won by appearances. It is won by what happens when theory meets reality. This single-force landing represents more than a tactical accident. It is a strategic opportunity, and unknowingly a strategic warning. Inside this aircraft lies not just American engineering, but evidence of something far more dangerous, an industrial system capable of producing power, durability, and complexity at a scale Germany has never faced. As the sun rises over the airfield, German engineers prepare to examine the machine piece by piece. They believe they are about to study an enemy fighter. What they are actually about to uncover is proof that this war is being decided far beyond the battlefield, inside factories, supply chains, and production lines stretching across an entire continent. The officer called to examine the captured aircraft is not a fighter ace. He doesn't wear victory marks or boast combat hours. Oberleutnant Schultz is something far more dangerous to myths and slogans. He is an engineer. Before the war, Schultz designed aircraft, not tactics. He lived in numbers, tolerances, stress limits, and production schedules. His job inside the Luftwaffe is simple on paper: analyze enemy aircraft, identify weaknesses, and recommend countermeasures. In reality, his task is far more uncomfortable. He must translate physical reality into conclusions that leadership may not want to hear. Schultz does not believe in intuition or national pride. He believes in mathematics. Metal either holds or it fails. Engines either deliver power or they don't. Factories either produce at scale or they collapse under demand. When Schultz arrives at the airfield and sees the American fighter for the first time, he reacts like everyone else. It looks wrong. Too big, too heavy, too unsophisticated to be dangerous. German aviation doctrine prizes efficiency and elegance. This aircraft looks like excess made of aluminum. But Schultz has learned something crucial long before this moment: wars are not won by elegant ideas. They are won by systems that work under stress. He orders the aircraft secured, photographed, cataloged. No rush, no assumptions. Every bolt matters. Every design choice tells a story. And as Schultz prepares his notebooks and tools, he is unaware that this inspection will not simply reveal how the enemy fights, but why Germany is already fighting a losing battle it has not yet recognized. Because once engineers start counting, ideology stops working. The first emotion the aircraft provokes is not fear. It is contempt. German pilots and officers circle the captured fighter, slowly, hands on hips, heads tilted in disbelief. Up close, the American machine looks even worse than expected. The fuselage is thick, swollen around an oversized engine. The nose is blunt. The proportions feel wrong. This is not how a proper fighter is supposed to look. Someone mutters the nickname already spreading through Luftwaffe squadrons, the flying milk bottle. A joke, half insult, half reassurance. This thing is too fat to be dangerous, too heavy to be agile, too crude to match German engineering. German aviation culture values refinement. Every kilogram is shaved. Every curve has purpose. Aircraft like this look inefficient, wasteful, almost lazy. To many watching, the conclusion seems obvious. The Americans don't know how to build elegant machines, so they compensate with size. Schultz listens but says nothing. He understands why pilots think this way. In air combat, instinct favors sleekness. A slim aircraft feels faster, smarter, superior, but instinct is not data. And war punishes those who confuse appearance with capability. As he studies the aircraft's bulk, Schultz does not see ugliness. He sees intention. Thickness means structure. Weight means margins. Excess means choices made without fear of scarcity. The Americans did not accidentally build something this large. They chose to. And that choice hints at a strategic reality German designers cannot afford when you are not constrained by engines at their limits or factories stretched to breaking. You can design for survival instead of perfection. To the pilots, the P-47 looks ridiculous. To an engineer, it looks like a machine built by a nation that does not expect to lose pilots or aircraft because it knows it can build more. And that difference, subtle as it seems on the tarmac, is where the balance of the air war quietly begins to shift. The numbers confirm what the eye already suspects. Fully loaded, the American fighter weighs nearly 8 tons, twice the mass of Germany's frontline interceptors. In German design culture, that figure borders on heresy. Every kilogram is an enemy. Weight steals, climb rate, agility, acceleration, the holy trinity of dogfighting. German engineers spend years shaving grams from airframes, pushing engines to their limits just to claw back performance. Lightness is survival. So how does an aircraft this heavy even get off the ground? That question cuts deeper than performance charts. It exposes a fundamental divide in how the two nations fight wars. Germany designs aircraft at the edge of possibility. Engines run hot. Structures are thin. There is no margin for error because there is no excess power to carry it. Precision is mandatory because resources are scarce. America designs aircraft assuming abundance. Abundant fuel, abundant aluminum, abundant engines powerful enough to drag extra weight into the sky without apology. Where Germany trims, America reinforces. Where Germany optimizes, America overbuilds. Schultz begins to understand the implication. Weight in this context is not a flaw. It is insurance. Insurance against battle damage, against pilot error, against harsh operating conditions, against the chaos of war itself. This aircraft is not designed to win elegant duels. It is designed to keep flying when things go wrong. And that realization triggers an uncomfortable thought. If the enemy can afford to build fighters this heavy and still make them fast, lethal, and reliable, then the true battlefield is no longer the sky above Europe. It is the factory floor thousands of miles away. The P-47's mass is not a mistake. It is a message, a declaration that one side is fighting with constraints while the other is fighting with capacity. And capacity, Schulz knows, decides wars long before the first shot is fired. Schulz begins where every engineer begins, with the engine. When the cowling panels come off, the conversation around the aircraft stops. In front of them sits a machine that immediately rewrites expectations. 18 cylinders, 2 massive radial rows, a power plant so large it explains the aircraft's entire shape. The fuselage is not bloated by accident, it is built around this engine. But size alone is not what unsettles Schulz. Germany has built powerful engines before. What arrests his attention is execution. Every cylinder is uniform, every connection precise. No uneven machining, no shortcuts, no signs of overstressed components pushed beyond safe margins. This engine is not fighting physics, it is working with it. Schulz starts calculating displacement, compression, cooling airflow. Even without full data, the conclusion is unavoidable. This engine is producing at least 2,000 horsepower, possibly more, with boost. That is not just superior performance, it is superior headroom. German engines reach similar outputs only by running at their limits. High temperatures, narrow tolerances, short service lives. This American engine, by contrast, looks relaxed, overbuilt, designed to deliver power day after day, not just for a brief burst of perfection. And then comes the most disturbing realization of all. This is not a rare masterpiece. It is not a hand-built marvel reserved for elite units. This engine is clearly designed for mass production, repeatable, standardized, reliable. Schulz understands what that means instantly. The Americans are not gambling everything on brilliance. They are betting on consistency, on factories capable of producing power without compromise. If this is the heart of the aircraft, then Germany is not facing a better fighter. It is facing a better system. As the inspection continues, Schulz looks for what German engineers have learned to expect by 1943: compromise, rough finishes, simplified parts, evidence that designers were forced to work around shortages. He finds none. Instead, every component tells the same unsettling story. High-grade aluminum alloys, precision bearings, clean machining lines, uniform tolerances repeated again and again, as if scarcity simply does not exist. This engine is not built despite limitations, it is built as if limitations are irrelevant. Schulz runs his fingers along a cylinder head. The metallurgy alone would strain German supply chains. Strategic materials like this are rationed, substituted, diluted back home. Yet here they are, used generously, almost casually. Then an assistant notices something that sharpens the implication even further. Each cylinder is individually removable. No major teardown, no full disassembly. Damage one section, replace it, return the aircraft to service. That detail changes everything. This engine is designed with the assumption that it will be damaged and that it will be repaired quickly. It assumes spare parts will be available. Skilled labor will exist. Time will not be a critical constraint. German engines are not designed this way because they cannot be. Repairs are slow, labor-intensive, and often uneconomical. Aircraft sit grounded while mechanics struggle against shortages and complexity. The American design assumes the opposite reality: abundance of parts, time, and manpower. It assumes a logistics system that works. To Schultz, this is no longer just engineering. It is strategic evidence. Every removable cylinder, every precision-cut bearing points to an industrial base operating on a scale Germany cannot touch. The engine is not merely powerful, it is confident. And confidence in war is usually backed by factories. What unsettles Schultz most is not what the engine can do in the air, but what happens after it lands. The removable cylinders are not a clever convenience. They are a declaration of intent. This aircraft is designed for a war measured in sorties, not duels. It assumes damage is routine, not exceptional. And more importantly, it assumes damage can be fixed quickly. German aircraft are built for performance. First, maintenance; second, repairs demand time, skilled labor, and full engine teardowns. A damaged fighter often means a grounded fighter, and a grounded fighter is effectively lost. The American engine tells a different story. A cylinder shot through by flak does not end the aircraft's career. It becomes a line item. Replace the part, log the hours, fly again tomorrow. Schultz realizes this machine is not optimized for brilliance, it is optimized for availability. It is built to maximize the number of aircraft ready to fly on any given morning. And in an air war, readiness is power. Every hour saved in maintenance becomes another escort mission, another interception, another pilot brought home alive. Multiply that across hundreds, then thousands of aircraft, and the strategic picture shifts dramatically. Germany fights with limited machines pushed to exhaustion. America fights with systems designed to absorb wear and keep moving. This is a war of endurance, not elegance. And standing on that airfield, Schultz understands something chilling. Even if German fighters were equal in combat, which they are not, they would still lose to an enemy that can repair, faster rotate crews, and return aircraft to the sky without pause. The P-47 is not just built to fight. It is built to outlast. Then Schultz sees what truly tightens his stomach. Hidden deep inside the fuselage is a maze of ducting, thick, heat-scarred channels running from the engine exhaust all the way to the rear of the aircraft. At the end of that path sits the real secret of the P-47, a turbo supercharger. On paper, German engineers understand the concept. In reality, they have never made it work at scale. This system uses exhaust gases to spin a turbine at tens of thousands of revolutions per minute, compressing air and forcing it back into the engine. The result is brutal, sustained power at altitude where thin air normally strangles performance. But the engineering cost is enormous. The ducting must survive extreme heat. The turbine demands bearings of exceptional quality. The entire system must be perfectly balanced, perfectly calibrated, or it destroys itself. Germany experimented with such systems. They failed. Materials cracked, bearings seized, Production proved too complex, too fragile, too demanding for an industry already stretched to the breaking point. Yet here it is, installed not in a prototype, not in a test aircraft, but in a frontline fighter being produced by the hundreds. Schultz understands the implication instantly. This machine assumes access to advanced metallurgy, precision machining, and long supply chains that function without interruption. It assumes factories that can build complexity repeatedly, reliably, and quickly. The turbo is not just a performance advantage. It is a declaration of industrial dominance. For the first time, Schultz is no longer thinking about how to counter this aircraft tactically. He is thinking about something far more disturbing. How do you fight an enemy whose technology reflects an economy you cannot reach? The answer, he knows, is that you usually don't. You endure until you can't anymore. With the turbo system mapped out, the numbers fall into place. Schultz does the math, then does it again. The conclusion is unavoidable. At altitude, this aircraft does not merely survive, it dominates. Above 25,000 feet, the air thins and engines begin to suffocate. German fighters feel it first. Power drops, climb rate fades. Controls grow sluggish as pilots struggle to stay with bomber formations. Mechanical superchargers reach their limits, and beyond them, performance simply collapses. The American fighter behaves differently. With its turbo system feeding dense air back into the engine, the P-47 keeps pulling. Full power, full speed, full authority precisely where the air war is decided. This is not an advantage at the margins. It is a structural imbalance. German fighters must climb to intercept bombers. That climb costs fuel time and engine life. By the time they reach altitude, they are already compromised. The P-47 arrives fresh, fast, and waiting. This changes everything. Escort fighters no longer need to dive down and disengage early. They can stay with the bombers, fight repeatedly, and choose when to engage. The sky above the bombers becomes hostile territory, not for attackers, but for defenders. Schultz understands the strategic effect instantly. Air superiority is no longer won through individual skill. It is enforced by altitude control. Whoever owns the thin air owns the tempo of the battle. And now, the Americans own it. This is why German pilots report the same thing again and again, encounters that begin on equal terms and end with the American fighter accelerating away, climbing when it should be slowing, fighting where it should be gasping. The P-47 is not just a better aircraft at height, it is a gatekeeper. And once the enemy controls the altitude, the rest of the air war becomes a matter of time. After hours of measurements and calculations, the hangar grows quiet. The facts are no longer abstract. They are written in figures, tolerances, and diagrams spread across Schultz's notebook. One of the junior engineers finally asks the question hanging in the air: "Can we build this?" Schultz does not answer immediately. He knows what the question really means. It is not about copying a component or improving a design. It is about whether Germany still has choices. He shakes his head. Not with current capacity, not with factories under bombardment, not with shortages of high-grade alloys, skilled labor, and time. Replicating this system would require precision machining at a scale Germany cannot sustain while fighting for survival, and even attempting it would slow production of the aircraft they already struggle to build. The room absorbs the answer in silence. This is the moment the problem reveals its true shape. The P-47 is not dangerous because it exists. It is dangerous because it exists in large numbers and can continue to exist in larger numbers tomorrow. Germany can design brilliant machines, but brilliance does not multiply itself. Industry does. Schultz understands now that the war has crossed a threshold. Tactical adjustments might reduce losses. Smarter engagements might buy time. But time is exactly what Germany lacks. The Americans are not racing toward a breakthrough. They are marching toward inevitability. From this point forward, every German aircraft shot down will be harder to replace than the one before it. Every American aircraft lost will be an inconvenience, nothing more. The question has been answered. The war cannot be won by matching the enemy, only by surviving them. And even that Schultz suspects may no longer be possible. Schultz moves from the engine to the scars left by combat, holes torn through aluminum skin, shrapnel cuts along the wings. Damage that, on a German fighter, would have meant a death spiral. Yet this aircraft flew back and landed under control. He studies the structure carefully. Thick gauge aluminum skin, heavy internal framing, redundant control runs. This machine is not fragile. It is resilient by design. Then there is the cockpit. Armor plate surrounds the pilot from multiple angles. The windscreen is thick armored glass, far heavier than anything used in German fighters. Weight that German designers would never allow. Weight that saves lives. But the most important shield sits right in front of the pilot. The radial engine. Unlike liquid-cooled inline engines, it has no vulnerable coolant system, no single puncture that guarantees failure. Cylinders can be destroyed and the engine will still run. Power reduced, yes, but alive. Flying. Schultz reviews damage reports from Luftwaffe units. Again and again, pilots describe the same impossible sight, pouring cannon fire into P-47's and watching them refuse to die, limping away, climbing out, returning the next day. German fighters cannot do this. They are optimized for speed and climb, not survival. One good hit is often enough. The pilot does not get a second chance. An engineer beside Schultz mutters the obvious conclusion. It's over-engineered. Schultz nods but adds the part that matters. They can afford to be. They have the power to carry armor, the structure to absorb damage, the industry to replace what breaks. Germany cannot. This aircraft is not designed to win every fight. It is designed to ensure the pilot comes back alive to fight the next one. And in a long war, survival is not a detail. It is the strategy. Schultz saves the wings for last. When he counts the gun ports, his expression hardens. 8, 4 in each wing. Heavy machine guns, not rifle caliber weapons, but .50 caliber Brownings designed to tear through metal, not fabric. He does the math instinctively. Each gun carries hundreds of rounds. Together they unleash more than 100 bullets every second. A 1-second burst saturates the target. A 2-second burst erases it. German fighters rely on precision, limited ammunition, short firing windows. Pilots are trained to aim carefully, conserve rounds, and break away. Miss the moment and the opportunity is gone. The P-47 does not fight that way. It overwhelms. This aircraft does not demand perfect aim. It creates a cone of fire so dense that anything entering it is shredded. Armor control surfaces engines. None of it is safe. Against lightly built German fighters, this is not an exchange. It is a verdict. Schultz studies the ammunition itself. Heavy, high-velocity projectiles designed to retain energy at range. These rounds punch through structures that German aircraft were never meant to resist. Now the pilot reports make sense. A wall of lead, instant destruction, no chance to return fire. The implication is brutal. Head-on attacks, the classic Luftwaffe tactic, are no longer viable. The closing speed is too high, the return fire too dense. Survival becomes a matter of luck, not skill. Schultz writes the recommendation: plainly avoid frontal engagements. Probability of survival minimal. But even as he writes it, he knows it changes little. Because firepower like this does not just win dogfights. It shapes behavior. It forces the enemy to disengage earlier, attack less often, and hesitate longer. The P-47 does not merely shoot down aircraft, it intimidates the sky itself. And once fear enters the equation, the balance of the air war shifts again, quietly, decisively, and without mercy. By now, Schultz no longer sees the P-47 as a collection of parts. He sees a pattern. The engine demands precision machining and high-grade alloys. The turbo system requires advanced metallurgy and flawless production discipline. The airframe consumes massive quantities of aluminum. The armament depends on an industrial ammunition pipeline that never stops. Each of these systems alone would strain German industry. Together they form an aircraft that should not exist, at least not in large numbers. Yet it does. That is the revelation. The danger of the P-47 is not any single feature. It is integration. Everything works together, not because of brilliance, but because the industrial base behind it can support complexity without collapsing. Schultz understands this is no longer a technical problem. It is a strategic imbalance. Germany can build excellent machines in limited quantities. America builds very good machines in overwhelming numbers and keeps improving them. This aircraft assumes stable power grids, uninterrupted logistics, deep reserves of raw materials, and a workforce that can sustain precision over time. It assumes factories that are not being bombed nightly. It assumes an economy designed for expansion, not survival. For Germany, the war is about managing scarcity. For America, it is about exploiting abundance. Standing over the dissected fighter, Schultz realizes something chilling. Even if Germany somehow matched this design, tomorrow it would still lose. Because copying one aircraft does not replicate the system that produced it. The P-47 is not a weapon. It is evidence. Evidence that the war has already shifted beyond tactics, beyond pilots, beyond courage. It has become a contest of production lines and material flow. And in that contest, the outcome is no longer uncertain. It is only delayed. Schultz requests the production data. What he receives feels unreal. American factories are producing fighters not by the dozen, but by the hundreds every single month. Entire assembly lines run without pause. Shifts overlap. Output rises even as complexity increases. The P-47 is not a peak effort. It is routine. Germany's numbers tell a different story. Production struggles to replace losses. Bombing disrupts supply chains. Skilled workers vanish into the draft. Every increase in output demands sacrifice somewhere else. Nothing comes without cost. Schultz lays the figures side by side, and feels the weight of inevitability settle in. This is not a race. It is an avalanche. Worse still, American aircraft are heavier, more complex, and more resource-intensive, yet they are produced faster. One American bomber consumes the material and labor of multiple German fighters, and still, the Americans build thousands of them. This is the moment. The air war stops being about pilots and starts being about arithmetic. Every German loss matters. Every American loss is absorbed. The exchange rate is unforgiving. Even perfect tactics cannot compensate for a 3-to-1 production gap, especially when the enemy's machines are stronger to begin with. Schultz understands now that strategy has shifted into a domain Germany cannot influence. No tactical brilliance can erase a deficit measured in aluminum oil, electricity, and labor hours. The Americans are not trying to outfight Germany in the sky. They are trying to bury it under output. And once production reaches this scale, the battlefield becomes irrelevant. The outcome is decided long before the aircraft ever meet, sealed in factory schedules, shipping manifests, and monthly quotas. At this scale, numbers are no longer statistics. They are weapons. And Germany is standing in their path with nothing left to counter them. 15. Schultz knows the report he is about to submit is dangerous. Not because it is wrong, but because it is right. He writes carefully, clinically, stripping emotion from every sentence. The P-47 is technically superior in multiple domains. Its performance at altitude cannot be matched. Its durability reduces pilot losses. Its firepower alters engagement geometry. Most critically, Germany lacks the industrial capacity to replicate these systems at scale. The conclusion is unavoidable. Continued attrition against such an enemy will lead to unsustainable losses. In plain terms, Germany cannot win this fight. When the report reaches higher command, the reaction is exactly what Schultz expects: unease, silence, dismissal. The findings are labeled pessimistic, defeatist, politically unacceptable. Reality conflicts with belief and belief wins. No revisions are requested. No counter-analysis commissioned. The document is filed away. What Schultz has written is not intelligence, it is heresy. And yet history begins to move exactly as his numbers predict. P-47s appear in ever greater numbers. German losses mount. Experienced pilots vanish faster than they can be trained. Tactical adjustments come too late, applied too slowly against a force that no longer needs perfection, only persistence. Standing at his desk, Schultz understands the final irony. The war is not being lost because Germany lacks courage, skill, or innovation. It is being lost because truth has no authority in a system built on ideology. The P-47 was never just an aircraft. It was a warning. One that arrived intact, was examined in detail, fully understood, and then ignored. By the time the consequences become impossible to deny, the outcome is no longer in question. The war has already been decided, not in the skies over Europe, but in the factories that never stopped running. The story of the captured P-47 is not about one aircraft, one engineer, or one report buried in a filing cabinet. It is about a fundamental misunderstanding of how modern wars are won. Germany believed victory could be engineered through brilliance, discipline, and willpower. America proved that wars of the 20th century are decided by factories, logistics, and scale. Schultz did not predict defeat through ideology or fear. He reached it through measurement, through metal thickness, horsepower margins, production rates, and repair times. The P-47 showed him that the United States was fighting a different kind of war, one where losses were planned for absorbed and replaced without pause. Germany was optimizing to survive. America was producing to dominate. By the time this truth became visible in the skies over Europe, it was already too late to change course. The outcome was sealed not by tactics or courage, but by capacity. In the end, the P-47 was not just a fighter, it was a forecast, and history proved it correct. History proved it correct. History proved it correct. History proved it